Welcome back. In this video, we will look at how product, process, and schedule design drive facility design and location. I'm Beli Zokur. Let's dive in. Before designing any facility, we must answer 6 fundamental questions. What the products, how to produce them, when, how much of each, for how long, and where. The first 5 directly shape the facility location and layout. Strategic facility planning is primary responsibility. It's the art and the science of using firm's resources, people, capital, technology to achieve business goals. Location and design decisions here have long-term impact. These elements are deeply linked. Product design defines what we make. Process design determines how to do it. Schedule designs tell us when and how much. Facility design integrates all three, answering the where and setting up the physical environment. Think of it as a pyramid. Product at the top, process in the middle, facilities at the base, supporting everything. Product design starts with aesthetic functions and materials, but it also shaped by manufacturing, marketing, and purchasing constraints. Industrial engineering and quality control influence production needs. Tools like quality function deployment (QFD) translate customer needs into technical specs. Benchmarking compares us to industry best practices. The outputs of product design are concrete. Exploded assembly drawings show how the parts fit together. Component part drawing detail each piece, and the bill of materials or BOM lists every component. It's the recipe for assembly. Today, computer-aided design, CAD design, let us create and manipulate 3D prototypes, analyze stress and visualize assemblies. Concurrent engineering overlap design stages, so manufacturing and service consideration come in early. This cuts the development time and cost dramatically. Process design answers how we produce. Should we make or buy? What equipment will we use in-house? How long does each operation takes? And crucially, which production method will shape the physical layout? For example, job shop or assembly line. 3 key issues: process identification, that includes make or buy analysis and creating part list; process selection, choosing operations, equipment, and raw materials; and process sequencing, deciding how components are assembled step by step. Make or buy is a managerial decision that affects facility scope. We ask, can we buy it or subcontract it? Do we have internal capabilities? Is it cost-effective? Is capital available? These choices determine vertical integration, how much of the value chain we control. The part list is a key input to facility planning. Here is an example for an airflow regulator. It shows part number, names, quantities, materials, and make or buy column. A bill of materials goes further. It's hierarchical, showing sub-assemblies built into the final product. Selecting the right manufacturing method is guided by experience, product requirements, available equipment, and production rates. Different facility might choose different process for the same product, but we need a consistent, rational procedures. Here's a systematic 5-step procedure. First, define operation precisely. Second, identify alternative process for each operation. Third, analyze those alternatives. Fourth, standardize the selected process. Fifth, evaluate and make the final choice. Let's walk through each of them. Step 1. Define every element operation required to make the product. No ambiguity. For example, drill 8 holes of 0.078-inch diameter. This is a very precise definition. Step 2 is define alternative ways to perform each operation. Maybe drill press or CNC mill or robotic saw. We are listing them all. Step 3. Conduct a true analysis. Consider cost, time, quality, reliability, and safety. Use data, not gut feeling. Step 4 is standardize the chosen method. This ensures consistency across shifts and reduce training costs. Finally, evaluate alternatives against your criteria, total cost, throughput, flexibility, and select the optimal process for each operation. The main output is a root sheet. Here is one for the plunger housing of our airflow regulator. It lists each operation number, description, mission type, tooling, setup time, operation time, and raw materials. The root sheet becomes the blueprint for facility layout, the material flow, and scheduling. That wraps up our look at product process and schedule design. Together they form the foundation for any effective facility layout and location designs. Thank you for watching.